So this is a video about using your calculator to find a minimum or a maximum for an optimization problem where you're looking to find kind of a real-world answer. So there's no work here shown, but this is a problem where you're supposed to minimize surface area given a certain volume and some information. And again, there's no work, but what we have here is a surface area formula given the fact that the volume was 40 cubic feet. And what we're going to do is type this surface area formula into our graphing calculator. Notice instead of w squared, I have x squared. But I'm going to go ahead and scroll through this. I've already typed it in, so you can see the full function there. But really what I want to talk about is how to use the window, how to find a good window for graphing this. So notice if I hit zoom and then 6, the standard viewing window from -10 to 10 and -10 to 10, it's not helpful at all. I'm trying to find a minimum, and I look at that graph right there that I just don't see enough information to know really what I'm looking for. And one of the main problems is I'm looking at ridiculous numbers. So let's look at the window. Remember, x is actually w. So there is no reason to look at negative x's at all. They don't make any sense in this problem. In the equation in general, if you were totally ignoring the problem, of course, x's can be negative. But since x is w, when you hit the window, there's absolutely no reason to look at negative x's. So I'm going to start at 0. Now the x max, that's a little bit more up to interpretation, but because my volume is 40 cubic feet, x max is probably not going to be 100. It's probably not going to be just 1. I think I'll leave it at 10. Now let's talk about the y's. My y is really my surface area. So again, you're not going to have a negative surface area. So in your window, when I go down to ymin, I'm looking at a -10 surface area. That's ridiculous. So I'm going to go ahead and start it at 0. And then y max. Now honestly, if the volume is 40 cubic feet, the surface area is probably going to be more than 10 square feet. So this is just a guess. Maybe let's just make it 20 and see what happens. That's actually going to be not the best choice, but still, I think I'll just change my scale also to 2. You don't really need to do that. It just makes the graph prettier. And now I will hit graph, and let's see what happens. And sadly, I see nothing. That's because my y wasn't really big enough, honestly. A little trick in figuring things out, just hit the trace button. You can see that when x is 5, y is 62, and the 62 is what you care about. My window wasn't big enough. Now I don't want negative y's, but I need my y's to be bigger than 20. Let's go up to, let's say 100. And again, I'll change my scale only to make my graph pretty. It really doesn't do anything in terms of solving the problem. Now when I hit graph, aha, there's the graph. And this is the minimum. So you can go ahead and use your calculator to find that minimum, but this video is more about finding the window itself so that you can find the minimum. So I'm going to stop there.